Alright, let's solve the 2D Lego problem. So 3D Lego problem is another tree problem, which is a smallest subtree with all the deepest nodes. So given the rule of the binary tree, the depth of each node is the shortest distance into the node. So that means if we saw the depth of each node is the shortest distance to the nodes, okay, we have to return the smallest subtree such that is contain all the deepest node in the original tree. So a node is called the deepest node if it has the largest depth possible among any nodes in the entire tree. The subtree is a node. The subtree of a node is a tree consisting of that node. So it's a little bit the technical jargons in here, plus the set of the descendant of that node. So I think if we have to check in here, let's consider this is one tree that we received, 351 and 6208 null, and 74. So we have to return the node with value 2. Okay, the reason why we need to return this, if we see the tree like a letter, so this is a level 0, level 1, level 2, and this is a level 3. So 1, 2, 3, 4. So among these level 4, the deepest nodes in here is 7 and 4. And then we have to return the node of that leaf, which is 7 and 4 is the leaf in here, the node is a 2. So I think that is a recursive problem. We could simply like concurrently going through like, hey, what is in the left and what is in the right. The same for here, hey, what is in the left and what is in the right. The same for this one here, what is in the left and what is in the right. Until we saw no values in here. At the end, we will end up in here, hey, what is in the left, what is in the right. So if really no value, we just return the whatever the node of left or right. That will be our solution for us. If there's only one numbers in here, let's consider with something like this. And then in the middle is just 1, so we just return the 1. So 1 is the deepest node in the tree. What about the another example given here? So we're given like 0 and 1, 3. It will be like this. 1 and 3. And the null and 2 will be like this. So like this, like this. Why is it like that? Okay, I need to delete that. Like that, and then like that. So we just need to return the, wait, what did I do wrong? 0, 1, 3 null, and this is 2. So the deepest node in here is a 2 in here. Okay. So we have like 2, 1, 0 directly. So but 2 is the smallest in here. Okay, got it. I think I could simply solve this problem by creating the depth search, since we need to go all the way down. So let's call it depth search. And then I'm gonna accept the tree node exactly as method from the solution, which is a subtree with all deepest. And then I just return the depth in here, which is an integer for earths. And then nodes, which is a tree node. We just need to return it. So this is the tuple data types in here. In Swift, we can create the custom data type like combination of string, integer, or table, or float by using the open and close parentheses in here. And then we will check like node is still have a value or not. If not, we just return the 0 as a depth and then nil as a tree node, since the node is not valid anymore, we just return the nil for the tree node. And then in here, we can do is like that we solved in like 2 or 3 days ago. They're exactly the same. Left will be the DFS of node.left, and then right will be the DFS of node.right. So after we check all that value, what we can do is if left of depth, so where do we get the depth values, which is in here, is greater than right dot depth. That means left is slightly greater than the right for sure. In that case, we just return the left dot depth plus 1, and then we will just return the left dot node. Since left is the longest node in here, why don't we return the node of the left and then plus 1 to the depth. And then else if we will check like right dot depth is greater than left dot depth, that means it's vice versa with the previous condition, and then we just return the right dot depth plus 1 and right dot node. So that is how we do it. And then last but not least, this is the final condition where I mentioned about. So we are in the situation like in the scenario like here. I need to delete that. This is so ugly. Okay. So we are in the situation with the 2 in here. So pretty sure like whether we go left or right, the value will be exactly the same. So we can choose like left or right, whatever we want here. Let's consider left dot depth plus 1, and then we just return the node in here. So, and then we need to call our only one method in here, which is a depth search of root dot node. Yeah, I think that is the solution. Let's try to run it for is pass all the XML or not. Yeah, I think okay, I will try it out. What if we're for the right dot depth? That would be exactly the same because we are at the end of the node of 2, and then we have 7 and 4 in the left and right. So no matter which leaf we choose, the answer will stay the same. So I'm going to submit my solution. I believe the space and time complexity will be the O of n for this problem, since we don't use any other extra data structure and we are not having any other next step loop in here. So let's check together. Okay, time complexity of O of n, and then the space complexity also O of n. Yeah, that's all for it, and then see you in the next one. Thanks.